If you like your bling bike tech, then you will probably know about Zipp, a wheel and component giant. You'll see their hoops on some of the best pro race bikes in the peloton, and also they're on loads of people's wish lists. Today, we're joined by SRAM's product manager, Nathan Schickel, who's going to guide us through the history of this storied brand. And with me in the studio is a man that has ridden more Zipp wheels than Zipp themselves. Warren, I know you've got a lot of questions about the history of Zipp and where they see the wheel market going in the future. But first, I must say thanks to Zipp for sponsoring a trilogy of vodcasts. We're also going to be looking at why Zipp believes in hookless and how it tests its wheels. So make sure you're subscribed for both of those. Right then, gents, shall we get going? Because I kind of want to start at the beginning. So for those of you who don't know, Nathan, how was Zipp born and when?
So Zipp was born starting in, the company actually emerged in 1988. But going back to 1987, the founder of Zipp, Lee Sargent, was at a bicycle trade show in Anaheim, California. He was there not for bicycles, but he was walking through the show, saw disc wheels, which back in 1987 was a pretty were pretty crude technology, and his background was as a Formula One aerodynamicist and composites engineer, and he had recently moved to the United States to start working on IndyCar. And so, walking through the show, he saw disc wheels from several different competitors. The way the story was relayed to me was one weighed 7 pounds, another weighed around 5 pounds, and he thought to himself, well, I can definitely do better than these, and went back and in his garage over the winter created what became the first Zipp disc wheel that was launched with Zipp in 1988.
Wow, 87 and 88 was. What were you doing in 87? I wasn't alive.
I was, what was I doing? I would have been still studying and playing rugby full time.
Wow.
And riding bikes, obviously. Yeah, so Nathan, good to see you. It's been been a moment. But Zipp's earliest days, you were making the disc wheel and a tri-spoke. And yes, as early as like 1990, you won Kona with what was quite a radical design. And obviously Kona is triathlon. That's the Wild West as far as bike tech goes. They don't seem to believe in rules.
They don't care about aesthetics.
So I guess my first question would be, if Zipp was unleashed from the UCI regs, would you still be making wheels with spokes? Ooh. Because thinking about the motorsport heritage of Zipp, we haven't seen spoked wheels in it, motorsport of any form, be it 2 or 4 wheel, for 5 decades.
Yep. We no longer make a 3-spoke wheel because what we realized was that in bikes at the time and even some bikes today, a 3-spoke wheel doesn't work as well. And that's because of the turbulence caused by the larger spoke passing through the fork itself. And so oftentimes you'll have a negative aerodynamic effect to that type of wheel. That's why we shifted from the 3-spoke that we had, our 3000 wheel that we had back in the early 90s, to what we have today, which are carbon rims using steel spokes. I hope I'm answering your question, Warren. Basically, what we discovered is we can make wheels faster and not be a complicated full composite wheel.
Okay, that's good to know. And those early wheels, they were complemented by, and I'm not sure many people are aware of it, you had the 2001 and the 3001. So you made bikes, you made sort of beam-shaped tri-stroke TT bikes,
Yes.
Do you ever see the day when Zipp could return to that? I'm obviously thinking now Zipp's got the might of SRAM behind it, unleashing your design team, unleashing the nest, as it were, on creating a full, complete bike that everything works in unison with each other. Is that something that do you think that would excite the guys upstairs, as it were?
Probably. I don't see us going back to making bikes. And the primary reason is, as part of SRAM, a lot of SRAM's business is working with OE manufacturers, so bicycle manufacturers. And if we started making bikes, we would then become a competitor to our customers. And that doesn't make sense.
Okay.
That's disappointing.
Yeah. Yeah.
We were hoping.
But hopefully you won't rule it out. I'd love to see what your guys could come up with.
Yeah.
So anyway, getting back to the history, you start getting into racing back in 2000 with Lotto, and then you moved on to a hugely successful period with CSC. And then in 2006, Zipp were trying to sort of prove the validity of carbon rims in pro racing. So you did I remember seeing it at the time, a whole series of testing in Arenberg to prove that carbon rims could work on the toughness of Belgian cobbles. So how long did it take to get all of those riders to move over onto carbon? How quickly could you prove carbon was the way forward?
Not as quickly as we wanted to. So we took up the project to have a carbon wheel finish both Tour of Flanders and Paris-Roubaix in middle 2005. We had been working with CSC for several years. We had seen a lot of success in a lot of races, but they still would not ride carbon wheels in the cobbled classics, Tour of Flanders and Paris-Roubaix. And
sorry to stop you, Nathan, but
yes.
Were these full carbon wheels, or were they carbon fairings on an aluminium kind of box section rim? Because I just remember those early days being so complicated about kind of what you were getting.
So Zipp has never made a carbon fairing wheel.
Okay.
All of our wheels have always been a structural wheel. Over the the we've had a carbon and aluminum co-molded rim, but it's a structural carbon rim. So the spoke is attached to the carbon, not to the aluminum rim. Mm. Some of our competitors have relied on fairinged wheels for quite a while and still do. But our goal was to create a wheel that gave riders the ride quality and the durability that they needed to make it through a race like Paris-Roubaix. In 2006, it was either fall of 2005 or spring of 2006. I'm not sure which. We built, I think it was 24 wheels, and flew 2 engineers over to the Arenberg forest for a test with 3 of our riders at the time from CSC. And within about an hour and a half, they had broken all 24 of those wheels. And so we had planned to be there for 3 days, and very quickly there was a call back here to talk with management, and decision was, okay, box everything up, fly home, let's start over.
Obviously, so what happened with those wheels? Like, what did the riders do apart from literally just smashing them into cobbles to break them?
Well, so you have to think about the brutality of a race like Paris-Roubaix. So especially the Forest of Arenberg. Over the last several years, the race course has changed a little bit, and you can enter the Arenberg either going downhill or going uphill. And most often, the race enters the Arenberg going downhill. So the peloton, as a group, is entering the Arenberg between 55 and 60k an hour. And, it's 100, 110 guys hitting the worst cobbles that exist at super high speeds. And a lot of them are unsighted, meaning they're just following the wheel in front of them. So you can't steer around what's in front of you. And what's interesting is after you enter the forest, you have about 500 meters where it sort of drifts up a little bit and then it dips down again. And it's when it dips down again, you start to lose your momentum. And it's at that point that we start to see tire flats and wheel breakages. And so basically what the team was doing was they were simulating that exact event, rolling into the Arenberg forest at speed and seeing how far down the Arenberg forest they could get before they broke the wheel.
I mean, that's pretty brave of the riders, isn't it? You're charging into there probably at pro speeds at 60 kph.
Yeah.
That's very brave of the riders to take what was at the time unproven tech and, really give it the ultimate test.
And, to be fair, we had already had several years working with CSC, and they had helped us. We had looked at what fails a wheel and making sure that the wheel is safe so that we can make sure the wheel is going to make it through whatever event and allow the rider to get stopped. So that's the goal, right? Sometimes it doesn't always happen, but that was the goal. And, our goal in mind, this is back in the days of rim brakes. So if you cracked the brake track, you could feel it immediately. And so the goal was to make a wheel that made it through Paris-Roubaix, was durable enough to do that, and then get that wheel under the riders and get the riders' confidence. And so it took us about another year and a half before riders started riding on our revamped carbon wheels. Specifically the 303 model was the wheel that we really focused all of our efforts on. Getting those layups correct and getting the ride quality correct. And then from then it took us, I believe, another 2 years. 3 years. 2010 was when Fabien Cancellara won both Tour of Flanders and Paris-Roubaix on Zipp 303s.
That was a landmark year that you'd kind of picked out, wasn't it?
Yeah, I think, possibly landmark because that was the first time I went to Indianapolis to visit Zipp. And it was the advent of Firecrest. And I think Firecrest, more than any other wheel out there, I mean, head fans might argue about the Jet, but that wasn't a structural carbon wheel, but it was a similar shape. So you went from V-shape to the toroidal, and then came the Firecrest shape, which has basically set the template for the modern aerodynamic wheel.
Yes.
A sort of fat, blunted shape.
Yes.
What was that game-changing element that brought about Firecrest? How did you go from this kind of, everybody perceived that the V-shaped rim was just going to be faster and more aero, and I remember when I came out to Indy and saw Firecrest for the first time, you almost didn't believe it. You were like, what have they done? It didn't look fast, but obviously it was.
Yeah. So from the initial carbon wheels that we had, the 400 and the 440, those were just straight V-shaped rims. And then, over the years, we had developed into a semi-toroidal shape. So with a bulge below the brake track, and that specific bulge matched with the tire width of the time. And so that created the aerodynamics that allowed the airflow to stay attached to the rim all the way across the rim. And that was a big step. And then sort of coupled with tires getting wider around 2010. And when I say wider, I mean going from 20 to 23 or 25. Not
revolutionary.
Yeah. Not what we see today. The Firecrest rim shape came about partly because we were looking for a structure that could both absorb heat and impact in a carbon clincher scenario, but in a tubular scenario, provide better aerodynamics. And that's where that shape came from, was those studies in the wind tunnel.
That kind of that wheel set is so iconic for me because it spanned so much of my kind of early interest in early-ish interest in pro racing, but also it had some incredible moments. Like you have Cancellara winning Flanders and Roubaix and just all of those athletes. I think, didn't Dijkman win one of her worlds on those wheels as well? And you also had the incident with Van der Poel and Van Aert, where Van der Poel kind of does a bad dismount and puts his foot through Van Aert's wheel, and Van Aert goes on to finish that race on that wheel. So there's been so many iconic moments for that one wheel set.
I think so. I mean, and there was obviously lots of things that were being proved around Firecrest. I mean, I remember one story from, I think, one of the times I was with Zipp, and their engineers were talking through the process of what was then the 202 and the 303, because I think it was David Miller in 2016, his epic breakaway when he was riding for Cervelo, but he got caught at the end. And I was sitting talking to one of the Zipp engineers, and David had insisted on going on the lightest climbing wheel.
Yeah.
And they said, look, here's the data. If you'd been on 303, you wouldn't have got caught.
Yeah, but that's pro cyclist for you, isn't it?
And that was an interesting story. But I mean, I guess with Firecrest was so sort of iconic, and it was such effectively a game changer. And it's almost set the precedent for Zipp now, where it's kind of, we've seen in recent times, like the latest generation of that wheel, you help kind of herald in that super wide road rim,
Yes.
you along with guys like Envy and etc. And then now you've done it again with the 303 Explore. I mean, it's a massively wide rim. And in both cases, you seem to be ahead of the industry. I mean, the 303 Explore, which I've spent a lot of time on, and I really think is a great wheel, but it's sort of so far ahead of the industry. At the moment, it's effectively a one tyre wheel. I mean, that's got to be a challenge for you guys to. It's a bold step to go onto the market and not have that full gamut of tyre choice out there, but you believe enough in their technology to do so.
Yeah, and we had 2 tire partners to start with, and that's where we stand today with both Goodyear and Schwalbe. Goodyear making tires specific for it, and Schwalbe really looking at the way the tires work on the wheel and helping us understand that compatibility from a tire performance perspective. We understand tire retention and inflation and all of that, but not being tire experts, we're not going to understand necessarily the dynamics of riding a tire and what changes with that wide tire bed. But the story of 303 Explorer is actually really fun. This was back during the pandemic. I believe it was 2021, but that period blurs for me. So it could have been 2020. It could have been 2022. I don't know. Asked to join a meeting here in the office, sat down, got a presentation about an idea of a product and how it could revolutionize gravel racing, and then was handed a set of wheels and told, okay, we have time to go ride during the pandemic. Let's go ride our bikes. Here's a set of these wheels. We want to hear your opinions. And I've been lucky enough to test ride some prototype wheels over my time, and some of those rides have gone really well, and some of those rides have not. And the 303 Explorer, the first time I rode it, it was a different world. And what I mean is, we actually had a road tire on it, and I was riding it on the road, but just the feeling was different. Everything was muted, and it's an odd feeling to not, as a road racer. Like, I started, my first road race bike had down tube shifters and 19 millimeter tires, and I was told at the time, if your hands aren't going numb, you're not going fast. And, then to fast forward, I guess that's, I'm now approaching 40 years riding bikes, but, fast forward a little bit, and now I'm on a bike where things are so cushy. You're going fast because you have the data to show you're going fast, but it doesn't feel fast. And that's the really cool thing about 303 Explorer is, we feel like we have the ability to design ahead of the market. And sometimes that means taking a risk, like releasing a wheel that has limited tire compatibility. But it also gives us the ability to do what our mission statement is, which is make riders faster.
Right. I mean, if we go back to that period, 2010, that's when you first started talking about NSW. So
Yes.
the Nest Nest speed work. So, I remember when I was out there, you said, "Hey, come and go and have a look at the Nest," and it was an empty mezzanine floor above the factory. There was nobody in it yet, but that's where your engineers were going to go. And then over the years, that has changed to now, because you've got the manufacturing basically underneath your designers, you've the speed at which you can sort of design, develop, and rapid prototype and test on site. That's got to give you a competitive edge. I mean, was that always a big goal for you guys, rather than having to, model, et cetera, was, how much advantage do you think it gives you?
I feel like it gives us a huge advantage. Because we make our own product, our design engineers are working side by side with our manufacturing engineers. And, as the product manager, while I don't sit close to the factory, I'm about 150 feet from the factory versus the engineers who actually now have moved to an office within the middle of the factory. I'll get a message on Teams or a phone call and say, "Hey, come down to molding, or come down to wheel building, or whatever," and I'll get shown something, whether it's just to say, "Yes, this is okay. No, this is not okay," and we can maintain our standards, or it's, one of the engineers has gotten a harebrained idea and gone and tried it, and it's something that is pretty incredible because, with a lot of things in the bike industry, they're made by subcontractors. And so, if you want to make a change to your product, you have to write up a full engineering packet, give it to your subcontractor. Then it takes their lead time to make it. And whereas with us, if we want to try something out, it's a matter of weeks. So if we want to try a new rim shape out, we can get a tool made in a short period of time, in a couple of weeks. We can use existing laminates that we know, and we can have a rideable wheel in about 4 weeks. And that gives us an incredible ability to prototype, an incredible ability to innovate, that we feel puts us ahead of our competitors.
And how many prototypes would you say you go through before you actually reach a product that's kind of going to go to market?
I think it depends on the project, and it depends on the product.
I would say let's say for the latest kind of all road gravel wheels, these super wide ones, they are forward thinking. I assume that a few ideas got binned before you reached
absolutely
those actual wheels.
Absolutely. I don't know the actual number of prototypes that we've been through. I know that we have been through, I think it was 7 different rim designs. It was quite a few, and when I say rim designs, I mean each individual tool. So there was an investment of a molding tool created to that particular rim design. And so, that was a huge project, and that project started back during the pandemic, and we launched it in 2024. So it was effectively a 4-year project.
And then I guess we come kind of back in time a little bit to the time that I like to think of, where animals came to influence design, and everyone started talking about humpback whales and things like that.
Yeah, I mean, obviously that was the 454 NSW. I think it's where NSW suddenly became, the previous NSW wheels were just kind of, they were like the S-Works version of a Zipp wheel. They'd just been refined and lightened and ceramic bands, etc. But the 454 NSW was mad. The Biomimicry, I think you guys called it.
Yeah.
Really sort of set a precedent, set a standard. I mean, and it's been, I don't want to say copied's the wrong word, but it's been heavily influential on other brands. I mean, it's basically, that's Princeton's whole ethos, I would say. And then you've got Campag's new Shamal, Fulcrum Shark, and a myriad of Asian brands with a wavy rim design. I mean, it's kind of, How did we get to? How did you get to that point of that sort of outside the box thinking of going away from a round rim, as it were?
So, our designers, when we start looking at a new design or a new project, we'll have a period of time where there's no bad ideas. And we literally will take Post-it notes, have a clear white wall, write our ideas on that Post-it note and put it on the wall. And, from that, a lot of these sessions, they'll be 2 or 3 hours long. We'll have a whole bunch of ideas on the wall. And then it takes a smaller group of people to refine those ideas and choose, okay, we're going to chase this. We're not going to chase this, but maybe we'll table this idea. And, from that perspective, our team comes up with some crazy things. And, we also will sometimes 3D print, and we've been using 3D printed parts to test wheels in the wind tunnel for now 10 years or more. And we will 3D print rims, get them into the wind tunnel so that we can at least test an idea. And so the biomimicry idea that developed into the 454 and what is our sawtooth rim technology today came out of a desire to make a wheel more stable in higher wind conditions. And because what we were hearing, not necessarily from our professionals, but from the riding public, was I have a set of 404s or I have a set of 808s, but it's a windy day and I don't want to ride it on a windy day. And so what we felt we needed to do was create a wheel that was just as aerodynamic as, say, a 404, but did not have the crosswind sensitivity of a 404. And so that was the whole goal behind that project. And when you ride a deep wheel with a constant ID versus a deep wheel with one of our sawtooth rims, I've not had the opportunity to ride some of our competitors' rims, so I can't speak to their performance. But when you ride them on a windy day, you notice a difference, especially if you ride them back to back. And I guess that's where I'm sort of lucky. I end up doing a lot of what we refer to as ABA testing, where we will have a test ride set up, and we will ride laps of a course, change wheels, ride laps of a course again. And so that gives a really quick feedback of, oh yes, this is different. It's not. And we'll do it specifically. We've got a few different courses that can have really bad crosswinds so that we can have that feeling if we need it. And that's something that you immediately notice with the sawtooth rim technology, is being able to hold the bike steady and continue to ride in much higher wind conditions than you would previously.
Yeah, I mean, we're kind of getting close to up to date now, but the only other tech that I wanted to talk about, another one I've had first-hand experience of, is you guys got into mountain bike wheels, which thinking about the early days and most of the period of Zipp, you wouldn't have imagined it's something that would have been interested you. But then there was the Moto rim,
yeah, which
obviously then moved on to the 101. So I think for those who don't know, but that rim with its kind of ankling design, the way that the spoke and the spoke nipple integrates with the rim, just talk us through that, because I think that of all of the more recent rims that I've ridden from Zipp, I think that's close to being one of my favorites.
Yeah, and from that perspective, we have, going back in Zipp's history, we did have a mountain bike wheel. We had a structural carbon mountain bike wheel with an aluminum hoop. This is back in cantilever brake days, so that'll tell you how long ago that was. But fast forward, we had engineers who did a lot of mountain biking, and we're part of SRAM, and SRAM has a lot of mountain bike product, and we had an interest to look into that portion of the market, and some of our engineers had done some study on what was at the time the state of the art for a mountain bike wheel, and a lot of those mountain bike wheels were very stiff. And the reason they were stiff was they needed to be stiff to be strong, to endure the impacts that you see, specifically on an enduro type ride or race. And when our engineers started looking at it and talking to athletes, one of the things that came out was that they are having to run lower pressures than they wanted to run to be able to get the control that they wanted. And so what that developed into, okay, how can we create a way for the rim to absorb some of that? And so we started playing with different prototypes, and the 3.0 project, I don't remember exactly, but it was quite a long project because we would make prototypes, get them to the athletes, go do a test event, and get feedback. And it was much like the effort with the 303 at Paris-Roubaix. We would go, make product, break stuff, come back and learn from breaking stuff, and change it again and do it, just repeat that process over and over. And eventually we settled on that 3.0 Moto rim that is a single wall rim. So unlike most carbon rims on the market, which are double wall rims, it's a single wall rim, and it allows that rim, like you say, to flex like an ankle and actually move with the tire as it moves over terrain. And so that was, that was our entry into enduro mountain bike. And then, since then we've also released the 1.0, which uses some of those features, but we've moved back to a double wall rim to be able to create something a little bit lighter weight specific to XC.
I remember, I just recall you talking about the days of cantilever mountain bikes. I showed the MBUK lads Dugast tubular mountain bike tires, and Tom Marvin refused to believe that they ever existed. And then I showed him pictures of who's the Nino running tubular mountain bike tires way back, and I think it blew his mind that was ever a technology. But we are kind of coming right round to the present, and you've kind of rolled it into the gravel stuff with the 101, I guess, as well. And then a short time later, the 303 Explore came out. That was the SW model, wasn't it? And that had like a really interesting mix of wide internal, but also aero. And you partnered with Goodyear to create like specific tires for that. I guess, is that where you see the future of wheel design going, partnering with tires specifically? It's something we've seen a little bit of elsewhere.
Yeah. It's whether, is that the next sort of frontier of wheel design? It goes back to I think the last time I was over with you guys, which I think was for 858. It's sort of, it was in the pandemic when we had a sort of 4-month gap where everything went back to normal briefly. Yeah. And I managed to get to the States, come back, and then get locked down again. But I got to ride those wheels when I was out there. But all your engineers were talking about then was about ride quality. It's almost like we've mastered aero now. Now we want to make it better for the rider. And that wheel actually does prove it. I mean, that's one of the deepest road going rim designs, but supremely comfortable. So is that the thing? Is that you see that in the next frontier, and therefore you're going to need to bring in the expertise of tire manufacturers to achieve those goals?
Well, I'm going to answer your question in a roundabout way. So back in 2018,
I asked it in a roundabout way. So.
Back in 2018, we actually did a study, and this part of the reason why we wanted to do this study was in 2018 was also when we were pretty heavily working on 3.0 Moto, and we were seeing some interesting effects coming from what we were looking at as a very wide tire bed, 30 millimeters on that 3.0 Moto. And we wanted to understand, the difference between the wind tunnel and real world. Because for years we had relied on the wind tunnel to make a lot of design choices on our road wheels. And we had the opportunity to do a real world test in Hawaii on the Queen K Highway with a company called Aerolab Tech, and I believe they've shut down, unfortunately. But they had a way to put sensors on a bike and measure wind speed, and along with using SRAM's Tire Wiz technology as well as power meters. So we used a Quark power meter to collect data from the ride. And basically, we chose a section of that Queen K Highway, and the riders rode that section at 40 kilometers an hour using, and at the time, an 808 clincher. So we're before tubeless, we're still using tubes, and wide tires had not been optimized yet. So when you looked at a 28 millimeter tire, it was more of an endurance tire. It wasn't a race tire. And we tested a 23 millimeter, a 25 millimeter, and a 28 millimeter tire. And going into that test, our assumption, built from what we knew from the wind tunnel, was that 808 with a 23 millimeter tire was going to be the fastest setup, because that's what we knew. Coming out of that test, what we realized was a 28 millimeter tire at a tire pressure of around 70 psi was the fastest setup by a range of about 15 watts. And it was that got our engineers to start thinking about, okay, we can be in the wind tunnel and be making decisions that are actually making the rider slower. I remember around that time speaking to some of the engineers, and one of the engineers asked, do you want wheels to be faster or do you want them to be more aerodynamic? And, at the time, I thought those two equaled.
Mm.
And it was only when you start to see data like that real world test we did on the Queen K that, all of a sudden it's that mind blown event where, okay, our world has changed. And so we started looking at wider tires. We started looking at wider tire beds. And now, and that study is what led us to the idea of total system efficiency, where we're not just looking at aerodynamics, we're looking at the weight of the product. We're looking at the rolling resistance. So rolling resistance and vibration loss are two things that we feel we're on the forefront of. Rolling resistance, a lot of people really look at regarding just a tire. It's a tire performance metric. And it is. But also, too, the geometry of the wheel can affect the rolling resistance of a tire. And so what we saw in our internal testing is that a wider tire bed coupled with a slightly wider tire and lower tire pressures is faster. And that also led us to develop a tool within our test lab called the Rolling Road, which is this massive treadmill with a cage around it so we can have a safety harness on the rider. And on that rolling road, we can simulate everything from a smooth velodrome to the Arenberg Forest to an enduro track. And what's really cool is our test engineers have instrumented bikes, taken them to different areas of the world, and measured the surface vibrations, and use that to then change the ride on the rolling road and then correlate the two. So when we're testing on something like the Arenberg Forest or the cobbles profile on the rolling road, we know that is correlated to the Arenberg Forest in the real world. And so that gives us the ability, without getting on an airplane and flying across the world, to actually do testing and test out a theory. And we've done that with a gravel profile. We've done that with smooth and rough road profiles. We've even done some mountain bike style testing on the rolling road. And that really led us to where we are today with a wide tire bed, hookless wheel system, and running at much lower pressures than we ever assumed. Another personal anecdote from myself, like I said, my first road bike was a bike with down tube shifters and 19 millimeter tires. I was told to run like 140 PSI in those tires. And being a bigger rider, I've also always been afraid of pinch flats. And back in 2019, I was handed a prototype of what would become the 303 Firecrest as it is today. And the engineer told me, he's like, I said, what tire pressure should I run? I wasn't working on the project directly, but you hear things. And he said, oh, I'd started about 65 PSI, and I laughed at him. Like, I laughed at him. I said, okay, I'll see you tomorrow with a broken wheel, because as soon as I hit a pothole, something's going to happen. And, oddly enough, about 3 weeks later, I was on a business trip out in California and doing an early morning ride with a colleague, and that colleague didn't point out, we were actually late to get back to the hotel to get to our first meeting of the day. So we were going pretty quick, and my colleague didn't point out a pothole. And I just slammed my rear wheel into that pothole, and ended up plugging the tire, and I could only get about 20 PSI in the tire. And this was the point for me that really changed my mindset, because at 20 PSI, it felt like 110 PSI. The only problem was going around turns where the tire was a little bit, it didn't really support my weight. And so that changed my mindset with regard to tire pressure, because I had that ingrained in my mind that the tire had to be as hard as possible. That's how you go fast. And having that experience of, I'm going to ride on a 20 PSI tire, and it's going to feel okay in a straight line. I know in a turn it's not going to feel good. And, it was all during this time that we were working on total system efficiency. And as we got through the first generations of our launches, in 2020 with the 303 Firecrest and 303S, 2021 with 404, and 2022 with 808 and 858, we realized, and I think I've got my years right, I may be a year off, we realized, okay, the next step is to start working on tires. Because with hookless technology, tire technology was still in a catch-up phase, but also, too, we realized that we could take even further control of that system if we had the opportunity to design a tire around it. And that's the whole reason we started working with Goodyear. And then from the side comes the 303 Explorer development, which was going on during all of this time. And we realized quickly that we needed specific tires for that. Enter Goodyear again. And so down the road, I think tires specifically designed around a wheel system will optimize it. I don't think it's the only tire to ride. I think we need to be able to offer choice, so we need to stay within the bounds of ISO in some cases. But I think down the road, you'll see more tire and wheel systems where they're built together, because that allows that system optimization that we're looking for.
I guess that brings us on nicely to kind of what is next for Zipp, because I know that there's some tech that we can't talk about today, but we do seem to be having many discussions around ever increasing tire widths on road and gravel. So do you see that as the future of fast wheel design, or will we reach kind of peak width quite soon?
I'm trying to think of the best way to answer that question.
I love stumping people. I mean, because the discussions we've had in the office, is like, obviously Pirelli have made, made some headlines with their new 40mm wide race tire, effectively, and all the talk about the coming gravel season, the gravel race season. Most of those riders are all talking about they want to be using 2.2-inch tires, and so obviously we're kind of trying to gauge where that is, and have we reached peak width yet? I mean, if we'd asked that 10 years ago about a 25, we probably would have said, yeah, we're about there, but it seems ever changing.
So I think that for the everyday rider, a bike that is able to accept a tire between 40 and 50 millimeters, and a road wheel set with a 40 millimeter tire is going to be probably one of the best setups you can have. And I say that from 7 months of experience on a similar setup.
I guess the only issue is we don't have the bikes yet.
On the other side of that, I think professional road racing, which in the past has governed a lot of this development, right? I think that's going to go even further toward F1, where we're going to see, and it's not something we haven't seen in the past, but we're going to come back to seeing specific bikes for specific events and specific wheel and tire setups for specific events. And so I think that's even more so coming around. And I think gravel is driving some of that. I think that just some of the science coming out and people realizing that, oh, if you make a 40 millimeter tire that's actually designed as a race tire, not designed as a tire to be bomb proof, then it's actually really fast. And so I think that's where the industry is today, like with Pirelli coming out with basically their top end race tire, but just in a wide section width. And that gives us that ability to now say, okay, do we have the ride quality we want from that tire?
I think that is an excellent place to wrap this up.
Certainly.
Thank you so much, Nathan. That's been a fascinating look back at the history of Zipp, which has included tubular mountain bike tires and all my heroes of cycling as well. But also some really interesting stuff that could be coming. Sounds like we all need road bikes that can fit 40mm tires.
Just start riding our gravel bikes on the road.
Exactly. Exactly. Warren, thank you very much for joining me.
It's been my pleasure.
Nathan, thank you very much for joining me.
Thank you very much.
And if you want to see more of this vodcast series, then make sure you are subscribed because we've got 2 more brilliant episodes coming up.